regression splines and there's a smoothing splines and there's kind of the local regression and the additive models. Certainly all these models, they are used to do this kind of nonlinear model. Usually we assume they have this additive structure. Today we will move to this kind of tree-based method. This is definitely was a pretty big class of the methods there. And they can also use to handle this kind of the nonlinear modeling. They actually is more general than that one. Okay. Let's certainly we will mainly cover the 4 methods. One is this kind of the tree-based method for the regression and the classification. Another one we will introduce this kind of the further development, like the bagging, random forest, and the boosting there. Okay. Let's see there. This, I don't know before you, got a touch of this kind of tree-based method or not. This is certainly, that's likely you can say the tree-based method, that's pretty intuitive. It's pretty easy to be interpreted. This is things there. Okay, the idea is pretty simple. The idea is to say, okay, this tree-based method usually involves the stratifying or segmenting the predicted space into the number of the simple regions. And actually, because this kind of the set of this kind of splitting, this kind of the splitting rules used to segment the predicted space can be summarized in a tree. So this kind of method are called the decision tree method. This one. Okay. And actually, pretty sure, just like we mentioned, for this kind of tree-based method, that's a lot of advantages. Tree-based method, first, definitely is pretty simple. It's useful for the interpretation. However, they have some issue. They typically are not competitive with this kind of best supervised learning algorithms. In terms of this prediction accuracy, like the support vector machine, like this kind of deep learning method, or just like a way later we will introduce this random forest and boosting. Certainly we will also introduce this kind of bagging, random forest, and boosting. Or this method, not just unlike before, we only focus on the single tree. This method will grow the multiple trees, which are combined to get this kind of single consensus prediction. Actually, combining a large number of trees can often result in a dramatic improvement in prediction accuracy. Certainly, at the expense the loss of the interpretation. This is sensitive. Certainly, single tree you can easily to interpret it what this means. But for this like the 100 or 1000, this is single trade to combine together. Definitely, they lost the trade structure. So that's also lost some of this interpretation. This one. Okay. Then we can take a look at this kind of the basics of the decision tree. This kind of the decision trees can be applied to both this kind of regression and classification problem. And let's first consider this kind of the regression problem, then move to the classification. Okay, and we can take a look at it. This is the example about this kind of the base salary data. And so certainly we say this is salary actually is this kind of the color coded from the low to this kind of high. Low is just this kind of the blue and the green, and the high is this kind of yellow and the red. Here we have the two predictors. 1 is the year. It's say that is a player. How many years of this player staying in the league? And another one is the number of the hits. Yeah, the number of hits this player has done. Yeah. Okay. Then we can take a look at it. Yeah, this is the decision tree for this data. You can say this actually looks pretty simple there. You say, okay, this decision tree here, certainly we have this load, we call it the top load. Yeah. You can say here we have this kind of the decision, the split rule. This is say years less than 4.5. So that just means this player staying in this league for 4.5 years. Yeah, certain left range is say low, right range is say yes. We say if it's less, if this player staying for less than 4.5 years, his salary is this one. It's around the 5.11. Yeah. If this player staying in the league for more than 4.5 years, then we will count another predict. Is the number of the hits. Yeah. So if the number of hits is less than around like the 117, then this say his salary is about like this kind of 6. Yeah. If it's larger than this, around this that's kind of 117.5, his salary is 6.74. So you can say that's very clear. It's very clear there. So very quickly you can see the data only thing is we can say that. Certainly here the data is like, can you see my whiteboard? Hello? Okay. So you can say for this data is this things there. Here this data is say we have the 2 predictors. Oh, wait 1 minute. Yeah, one is about the one predictor is years. Another one is the number of the hits. Third one certainly is the salary. Yeah, this definitely is our response. This is our response variable. We want to use these 2 predictors to explain this salary. Yeah. Yeah. The years of this player staying in the league and the number of the hits. Yeah, this one there. And so you can see here, then we can get back over this graph. Yeah, you can see this say, okay, how to form this kind of tree. So certainly in the beginning, you need to choose, okay, choose a predictor to do this kind of split. So you say, okay, first let's just choose the years as my splitting variable. Then another way I choose this kind of thresholding value. Yeah, 4.5. If less than 4.5, we move to the left branch. Yeah. Otherwise, if greater than this 4.5, you move to this kind of right branch. Then similarly, second case, you just choose this the hit as your predictor. Yeah, less than around this kind of 170 to this one. Right one is the this kind of to the, if greater than this kind of 417, you to the right side. So you can say finally you have how many this kind of load, this kind of leaf loads you have 1, 2, 3. Then certainly you say, okay, if I formed this kind of the tree, how do we make the prediction under this salary? So certainly you have the training data. You just say, okay, for example, for this one, this is just corresponding to this case. The years is less than 4.5. So we just take a look at for this training data, how many of this kind of data point have this years is less than 4.5. Then we just say, okay, we can simply using this kind of the sample mean as a sample mean of the salary as an estimate of this as a prediction for the salary. Similarly for other case. So this graph is looks pretty simple. Yeah. And let's check it. Okay. And this is okay. Yeah. And this I guess is easy to understand. We can take a look at a little bit more details. Yeah. For this heat data, certainly a regression tree for predicting the log salary of a baseball player, based on the number of the years that he has played in this major league, and the number of hits that he made in the previous years. So at given this kind of the internal load, like here we call it the internal load. Certainly if they have low children, we call it the leaf load. Yeah. Okay. In the internal load, this label, this kind of form, xj less than tk, certainly xj deload some predictor, tk definitely deload some this kind of some specified value. So that's indicated the left hand of a branch starting from that slitting, and the right hand branch corresponding to the xj is greater than equal to the tk. The split at the top of the tree resulting the two larger branch. Yeah. So you can say this left is the less than 4.5. Right branch is correspond to the greater than or equal to 4.5 years. Yeah. This tree certainly we say has a two internal load there. Yeah. And we have the three, this kind of, we call the leaf loads, or you can call it the terminal loads. Yeah, this is sensitive. The number in each leaf is the mean of the response for the observations that is forced there. So you can say like this one. So here we say we have done these things there. So actually you can say here we have the two this kind of the splitting there. One is this one, the years, whether it's less than or equal to 4.5. Yeah. Another one is this kind of the hits, whether it's less than or equal to the 117.5. Yeah. So certainly based on this one, you got this kind of the two regions. This is three regions. And let's get back to the graph. So you can say for here, this part just deload those. So you can say based on this one, you can get the first region is just like this one. Let's say this one. We say let's say the predicted vector years is hit. So that's just deload the years less than or equal to 4.5. Yeah. So you can say this correspond to the first load. This kind of first terminal load. How about the second? This kind of the terminal loads. Then we say we got the second region. Then here we say definitely the years is greater than 4.5, but the hits, the number of hits is less than equal to the 117.5. Yeah. Third one definitely similarly you can got it. Yeah. The only thing here the change is there. The hits is greater than 117.5. This is okay, you got these three regions. Then certainly you say, okay, I have the training data. This kind of training data there. So certainly this training data look like this one. You say your years, your hits, and your salaries. Certainly, let's say this one might be the N. Then we just say, okay, for each region, how many observations, how many training points located in this area? That is okay, you might be found it. Okay, 50 is fourth in the first region, another 100 to the second region, the 200 to the third region. Then certainly for all these regions, we just calculate this kind of average salary. Average salaries within this region, then we just using that one as the prediction for the salary. So this is the reason how do we got these numbers. 5.11, 6, and the 674. This is okay? Yeah, I guess that's very simple. Can you follow? Hello? Yeah. Just let me know whether it's okay for you or not. Yeah. Let's just check it. How many students have been come? Okay, then we can talk about a little bit this. I guess you might be care about this kind of midterm. Certainly last class we have discussed this kind of all midterm exam questions. Certainly I just finished the grading of this kind of the midterm exam. I also updated this, uploaded this grade on Canvas. You can check it. It's just like this one. I don't know. For this, I guess this kind of, for this online teaching, definitely the work is pretty challenging. So it's certainly it's okay. I will say it's not too bad, but definitely it's not so great, really. I calculated the after finish. Certainly, my grading is not very strict. So average, I only calculated the average. So average around like the 70. Yeah. I don't know. Certainly, I consider this kind of the online teaching might be pretty challenging. So I did a little bit of curve. So I guess everyone I just add 10. So then around like the average is 80. Yeah. Any question? Yeah. Any question? It's okay? Yeah, you just let me know. Yeah, you know, definitely online teaching might be a little bit boring, but yeah, certainly if you guys, I just posted. You can check it. Yeah, you can check it there. This I don't know. It's just like this one. I just like in the beginning of this class, I mentioned this. I don't think this class is pretty challenging. Yeah, the only thing definitely you need to spend the time. Yeah, certainly to study this, to study our this kind of the lecture material under the textbook. Certainly finish the homework and to do this kind of R levels, these things there. If you have done well, I guess that will be, usually that will be fine. But I don't know. This is just like this one. Yeah, I don't know. I don't know whether you guys really spend much time to work on it. Yeah. Certainly for all these things, this is pretty basic concept and method for the machine learning. So if in the future you really want to work on this kind of the data science or machine learning, to know this kind of the basic concept, the method and the algorithm well, that's pretty important. Yeah. I don't know. Yeah. It's just like no matter what kind of subject, If you don't spend much time to work on it, sometimes it's hard to know very well, even though they look pretty simple. Really. Yeah, especially you can say, for this kind of the introductory course, usually we covered a lot of material. Even though you look okay, it's not very challenging. We do not get involved too much in math. It's still a little bit conceptually discussion this kind of the method and this kind of the result. But yeah, you still need to spend the time to work on it. Yeah. Any question? Is it okay? For the midterm, you guys feel fine? Yeah. If you have any question, just let me know. Yeah. Yeah, it's just like this one. I guess this kind of online teaching definitely a little bit challenging to everyone, not just for the student. To us, it's the same situation. I'm pretty sure for the fall semester we will get back to the school. That will be better to everyone. Yeah, I don't know, but for online teaching, no matter what kind of the teaching style, if you do not spend the time to work on it, that's so hard to know very well. Yeah, it's actually some that kind of a little bit trick part. Certainly, most part is pretty easy to understand, but still have a little bit trick part. Might be, yeah. Okay, someone have some question? Mm-hmm. Okay. Yeah, that's true. Some student mentioned this online class is not as good as in person. That's true. Yeah, I'm pretty sure. This is okay. Yeah, but it happens. We have to, yeah, to overcome this kind of difficulty. Yeah, it's okay. I only remind you guys. Yeah, if you really want to understand some this kind of subject really well, to spend the time to work on it is pretty important. Not to say, okay, it looks so simple, then I don't need to spend much time to work on it. Not like that one. Yeah, it's okay. But I told you guys, overall it's fine. Really. Average score is like 70, looks fine. Yeah. Certainly, actually for this class, we do not have a lot of students, they performed too poorly. I guess only one student performed a little bit poorly. But for others, most students, fine. I guess performed fine. Certainly, I will not say the grade. Certainly, there are a few students that they really know the subject well. Yeah. Okay. And if no question regarding this midterm, let's get back our lecture. For the tree-based method is very important. Yeah. Actually, for this kind of the backing, boosting, and the random forest, they are very popular method. Just like the support vector machine and the deep learning algorithm, they are so highly applied in the practice. Yeah. Okay. That's this one. So you guys got some basic idea on this tree-based method. Yeah. So you can the result is like this one. So with this kind of tree stratified or segment the place this kind of the region this kind of the into the three regions of the predicted space. R1 is years less than 4.5, R2 is say this part greater than or equal to the 4.5, but the number of hits is less than 117.5. The third one is this part. Yeah. Okay, so in keeping with this kind of tree and log, so this is the three regions, R1 and R2, R3, we call the terminal nodes. It's just this one. This is 3-terminal loads. Yeah. Okay. Certainly the decision tree typically is drawn is the upside down. So this one, this upside down there. Okay, in the sense, the leaves are the bottom of the tree. This is just the convention. Yeah. The points along the tree where the predicted space is split, we call the internal loads. Yeah, so you can say this we do the splitting. So you have the 2 internal loads here. Yeah. And in this kind of heat tree, the 2 internal loads are indicated by this text: years less than 4.5 watt lot, or the heat less than 117.5 watt lot. This one. Okay, here then we can take a look at the interpretation of the result. Years definitely is the most important factor in determining this salary, and the players with the less experience certainly earn the lower salaries than the more experienced players. Definitely you guys know professional this kind of players, just like this one. Yeah. Given that the player is the less experienced, the number of the hits that he made in the prior years seems to play a little role in his salary. Yeah. So there's a reason here we do not have it. Yeah. We directly stop there. But among the players who has been in the major league for 5 or more years, the number of the hits made in the prior year does affect the salary. And the player who made the more hits last year tend to have the higher salary. We can say that. Yeah. So you can say here, certainly for all those players, they have stayed this league for more than 4 and 5 years. But you can say this depends on the number of hits he made in the previous year. Yeah, if he less than 117, then his salary is around the 6. But if it's more than this 117, his salary certainly he makes a higher salary for 6.74. Yeah, around like the 10% higher than those players there. Okay. Yeah. Certainly this surely this is very this kind of simplification. But compared with to a regression model, this is easy to display interpreted and explain. You can say here, no matter what kind of people, they can easily understand this graph very quickly, even though they do not this kind of received a lot of education. They quickly can understand what it really means. Yeah. Okay. Even though for the regression model has been looked pretty simple, but compared with this kind of tree-based method, still a little bit complicated. Yeah. Okay. And then we can take a look at the details of this kind of tree building process. So we will divide the predicted space. So let's say the set of the possible values for x1, x2 up to the xp into the j distinct and the non-overlapping regions. Yeah. For every observation that falls into the region Rj, we make the same prediction, which is simply the mean of the response value for that the training observations in Rj. So we say, okay, we have might be the 100 training observations located in this J's region. Then we compute the average value for the response. We use that guy as the prediction. Yeah, for this region there. Yeah, so it looks pretty simple there. This is okay. Yeah, so you can say the idea, the symbol is only 2 steps. First step to form this kind of split region. Yeah, to form these regions. They are distinct and the non-overlapping there, just like we did it here. Yeah, you form these regions there. Second step, based on this kind of the training observations falling in these regions, we make the prediction. Just use their sample means for the sample means of response as the prediction for the predicted vector falling this region. Now this we did it. Yeah. Okay. So this is two simple steps there. Okay. Then certainly we can say detailedly for the first step how to do the second step definitely not so big deal, easily understand. Then we can say that. So certainly another one certainly for this kind of the splitting region, we can say have any shape, but here we choose to divide this predicted space into this kind of the high dimensional rectangle or the boxes. This is just for the simplicity and for the ease of the interpretation and of the resulting predictor model. So we only care about this one. So this is region you can say for these things. They just like the box. Yeah. Okay. And this is this one. Yeah. Another one certainly we say, okay, what's our goal? The goal we want to find this kind of boxes that will minimize this kind of residual sum square. So this is given by the this. Yeah. Here this kind of the y hat Rj, this is the mean this kind of the mean response for the training observations with the J's box. This is okay. So you can say the only work we only need to find this kind of the boxes to minimize this residual sum squares. Below within each box, we will use this kind of mean response of the training observations in this box as your prediction. So you can say here what's your decision variable? Only these boxes is your decision variable. Yeah. Okay. This is okay. Okay. Certainly, unfortunately it's computationally infeasible to consider every possible partition of this feature space into the J boxes. So for this reason, just like before we do the variable selection, we will not use the best subset selection because there are too many possible subsets of the predictors. This one is the same thing one. We will take this kind of the top down, this kind of greedy approach, just like before we did using this kind of forward selection method or the backward selection method. Yeah, for doing variable selection. We take the top-down greedy approach. That is known as the recursive, this kind of the binary splitting. Yeah. This approach is a top-down because it begins at the top of the tree, then successively split the predictor space. Each split is indicated within the two new branches further down on the tree. So you can say here, how do we do that? Here. So you can say here, for this one, when we start from the top node, when you do this kind of splitting, you only need to choose one predictor. Which predictor you want to as your splitting predictor? Another one, what's your this kind of this threshold? Which value you use to do this splitting? Yeah, there's only two variables you need to determine. Yeah, and this is this one. So certainly that will simplify the problem a lot. Okay, this one. Yeah. Certainly this is the greedy. Yeah, because at each step of the tree building process, the best split is made at the particular step, rather than looking ahead and pick a sleep that will lead a better tree in some this kind of follow some future step. This is the same thing. This one exactly using the same idea like the forward selection strategy. Each one will only count it which predict can greatly improve greatly reduce the residual sum squares or not. This one, this is the same thing. We only take a look at the one step. Yeah, certainly you say, okay, if we consider the combinations of the several predictors, we might get a better this kind of split. That's true. But here, for simplicity, yeah, for the computational reason, we consider this kind of so simple approach there. Okay, then we can take a look at this things there. So first we will select a predictor like the xj and a cutoff point, the s, such that we will predict this predict space into the two regions. One is the xj is less than s. Certainly another region is the xj is greater or equal to s. So for this kind of splitting, we will lead to the greatest possible reduction in this kind of residual sum squares. This is the first one you did it. Like this tree you did it. Yeah, this is the first one. You choose the two values, which predict as your splitting variable. Another one is a cutoff point. Yeah. Okay. Yeah. Second step. Actually, we repeat this process. We're still looking for the best predict and the best cutoff point. This cut point in order to split this data forward such that to minimize this residual square within each of the resulting region. Yeah. Certainly, however, this time instead of the split the entire predicted space, we will split each of the previously identified region. So you can say here, just like here there. So you can say here we got the two regions there. This is this one less than years less than 4.5. Here is years greater than or equal to the 4.5. Then for the second region, we do the splitting. We just choose this hits, the number of the hits as your splitting variable and the cutoff point 117.5 as your cutting point. So you got another two. So that just means this region is split as another two sub-regions. So finally, you have got the three regions, 1, 2, 3. So you can say each splitting, you add one region, one new region there. Yeah. Okay. So certainly then we split one of the two previous identified regions. So right now we have three regions. Certainly again we will look to split one of these three regions forward. So as to minimize this residual sum square. So this process you can continue until certainly a stopping criteria is reached. For example, might be we just continue until low region contains more than 5 observations. We stop there. This is okay. For this, how to build this tree. This is okay. Yeah. Okay. This is how to form this tree. Certainly, second one is how do we do the prediction. We will predict the response for a given this kind of the test observation using this kind of the mean of the training observations in the region to which the test observation belong. So you can say, let's use this one to show it. So you can say here we have this one. We do the splitting. Here we do the forward splitting again. This is definitely the years less than 4.5. This is his less than 117.5. So let's say you have the data. So here you got the 3, you have the data. The training data. Yeah, training data just like this one. Like say years, the height, and the salary. Yeah, this one there. Certainly, in this is your training data. Definitely, you also have the test sample. You want to do the prediction. For example, for giving this kind of the values of the predictor, the years and the height. You want to do the prediction. Definitely, the salary is unknown. Yeah, this one there. So you can say for this one, definitely if you formed, then you just say, okay, this is you got the rating is R1, this rating is R2, this rating is R3. So certainly you can say for all these ratings, you can put your training data to these ratings. So you can say here, the R1 is just this one. You say this is years less than 4.5. Let's say we have the training data. Yeah, we have the training data. Like say the first observation, we say like say is this guy is 5 years. The height like say is 100. Like say salary is the 6.2 like this one there. So you can quickly say which region is belong. You say this guy is 5 years, so it's greater than 4.5. And the number of the height is the 100. But here this is, so it's less than 100, so it belongs to the second region. So that just means this observation, this is belong to the second region. Then we just assign all this training data to these 3 different regions. Finally, for this region, if we want to do the prediction, certainly for all these 3 regions, R1, R2, and R3, this is you formed by assigning all training data to these 3 regions. Then you calculate the average salary. Average salary there. Yeah, this like I say, this is a 5.8. Like I say, this is the this is 6.2. This is 7.1. So this is you got there. Then certainly you just say, okay, if I have a new sample, new this test sample is come. Okay. Yeah, the new test sample is coming. Let's say this guy, what we have, we said this guy is have stayed in the league 5 years. There's 100 there. How many salary we predict he can got it? We can say 5 years, 100 hits. Then he belong to the second region. That's true. So the average salary should be the 6.2. So we predict this player can make this 6.2, this salary. So this is just like we did it. This is okay. Yeah. Yeah, make sure you can understand well about this decision tree. Can you understand well? Hello? Okay. Okay. Then we prediction. We will predict the response for given this kind of test observation. We will directly use the mean of the training observations in that region to which the test observation belongs. So certainly a file-reaching example, we just take a look at here. This is Cynthia. So here you can see we formed this kind of the file regions there. You can see if we use a tree, it look like this one. Yeah. So you have a file region, so you have the 4 this kind of internal load. Yeah. Each splitting we will add 1 this kind of the this kind of the terminal load. So finally you got a 5. Certainly this definitely this graph, the first one, this kind of the upper left panel, certainly you cannot form by using this kind of digitation we used. Yeah. Okay, let's take a look at the explain. So top left, this is the partition of the 2-dimensional feature space that couldn't result from this recursive binary splitting. Yeah. And this top right, this is just the output of the recursive binary splitting on this kind of the 2-dimensional example. Bottom left is just this tree. Yeah, this is just the tree corresponding to the partition of the top right panel. This is equivalent. Yeah. Certainly this one, this is the bottom right. This is provide a perspective plot of this prediction surface. So they provide, you can, from here, you can get the salary information. You can get your prediction information there based on the height of this one there, this graph. Yeah. Okay. This is this one there. Yeah. Okay. Okay, that's another one. Certainly, except we need to generate this graph. Another one we also you say, okay, if we generate a graph, this kind of tree, a very big tree. Usually for this kind of big tree, it's easy. It's very likely to overfit the data. So another strategy in order to avoid this kind of overfitting. Another strategy is called the pruning. Pruning strategy will be used to avoid this overfitting. Yeah. Let's take a look at what time. Okay, let's take the 8 minutes break. Then we can get back to introduce this pruning tree. Yeah. Okay. You can get back this kind of 68058.